Hello everyone, my name is Aarohi and welcome to my channel. So guys, Ultralytics released YOLO11, which is the latest version of YOLO, and using YOLO11 we can perform object detection, image segmentation, pose estimation and image classification tasks. So in my today's video, I'll show you how to run YOLO11 on your local machines. So first of all, I'll show you how to set up the environment to run YOLO11 on your machines, and then we'll test all these pre-trained models of YOLO11. So guys, in my next video I'll show you how to work with the custom dataset using YOLO11, but today we are going to set up the environment so that we'll learn how to run YOLO11 on our local machines, and then we'll test all the pre-trained models. Okay, so let's start. So let's open command prompt, and I'm entering in a E drive, and in E drive I have a folder with the name of YOLO11. So I'm entering in that folder, and in this folder I have all the work which is related to YOLO11. So guys, whenever you try something new, I always recommend to work under a separate environment. So for this task also I have created a separate environment, and for that environment I'm using Python 3.10. So let me activate the environment. So this is how we activate the environment, and now let me show you the Python version I'm using for this environment. So the Python version is 3.10. So guys, next thing is to install the Ultralytics package, and we can install Ultralytics by simply writing pip install Ultralytics. But before that, we are going to install the PyTorch separately, because every PC have different version of CUDA, and then you need a different version of PyTorch according to that. So before running pip install Ultralytics, we will install the PyTorch version separately as per the CUDA version which we have installed in our PC. Okay, so and if you are working on a CPU, then you can skip this particular step, the PyTorch installation step, which I'm going to show you now. But if you are working on a GPU, then check the CUDA version of your machine. Let me show you how to do that. Just go to your C drive and then program files, and here you'll see NVIDIA GPU computing toolkit. Click on this and you'll see a folder with the name of CUDA if you have CUDA installed. So if you don't see this folder over here and you want to use GPU, then in that case you need to install the CUDA first. Okay, so in my case I have different versions of CUDAs. So these are the different versions I use for different versions of Pythons and for different environments. So for this tutorial I'm going to use CUDA 12.1 or 12.3. so these are the different version. Whatever version you see over here, so as per this version you will install the PyTorch, then only your PyTorch will work with GPU. Okay, so now we know these are the versions. Let's say I want to install the PyTorch with 12.1 CUDA version. So now let's go to the browser and here write download PyTorch and click first link, the official link of PyTorch. Just scroll down and here you'll see this screen. See, here you can see the CUDA version, CUDA 11.8, CUDA 12.1, CUDA 12.4. So in my case I don't have CUDA 12.4, but I have CUDA 12.1. so I'll click on it, and here you will get a command. Just copy this command from here, and then you'll go to your browser and you'll paste that command over here and then hit enter. Then you will have the torch and torch vision, this torch vision and torch audio installed, which will be compiled with CUDA 12.1. okay, so this is how you'll install the torch and torch vision. Now the next step is to install the Ultralytics package. Now just type pip install Ultralytics like this and hit enter. You will have all the installations done. So I have already performed this step, so that's why you are seeing here requirement already satisfied. Okay, so now that's it guys. These are the two steps which you need to perform to set up the environment to run YOLO11. Now we can run YOLO11, and for that to show you the demo I'm using a Jupyter notebook. So we'll see here. So this is the folder. I have a demo folder. Inside that demo folder, I have these two images and these two videos. So I have these videos and images for the testing purpose. So now let's create a new Jupyter notebook over here, right? Now guys, before moving to this practical implementation part, let's see the official GitHub repo of Ultralytics, where they have mentioned about YOLO 11 model. And here you can see that the Ultralytics YOLO 11, okay, just a second. Ultralytics YOLO 11 is a cutting-edge, state-of-the-art model that builds upon the success of previous YOLO versions and introduces new features and improvements to further boost performance and flexibility. But I tried to find out what are those new features and improvements so that I can discuss with you guys. So but till now, so today they released this model today only, so right now there is no information. I was not able to find this information which is related to this new features and improvements. So I'll discuss this part whenever I'll get the knowledge about those new features and improvements. So till now we can see the graph over here. So this is the blue one is YOLO 11, and you can see the performance is better as compared to the other YOLO models. Okay, now if you scroll down, so under this models you can see various different models of YOLO 11. So first one is the classification model, with the help of which we can perform image classification. Then with the help of this model we can perform object detection, and here we can perform image segmentation, and we can also perform tracking, and the last one is pose estimation. So these are the different models, pre-trained models, which we are going to test today. So when you scroll down here, you can find all those pre-trained models. So the detection model of YOLO 11 is trained on COCO dataset. Same, the image segmentation model is also trained on COCO dataset. Pose estimation model is trained on COCO dataset, and for oriented bounding boxes they have trained it on the DOTA V1. So if you'll see the Ultralytics document over there, you'll find out that their previous versions of oriented bounding boxes, they were also trained on this DOTA V1 version only, this dataset only. And for the classification model, the image classification model, they have trained the model on ImageNet dataset, which have, if you'll see here, which have 1000 pre-trained classes. Okay, so first we are going to try the first one, this detection model. When you'll click over here, you'll find out that these are the different variants of YOLO 11, and these are the different sizes, and here you can find the details about that. Now let's try these models one by one. So guys, here first we are importing the YOLO from Ultralytics, and then here we are providing the path of the pre-trained model which we want to use. So this is the object detection model, N model. This is the smallest model, okay? And then we are providing the image on which we want to perform the testing. And this dot show means it will show you the output image. Okay, so let me show you the input image first, this test.jpeg. So this is the image. Okay, so now we will perform object detection on this image. Let's run this code. Okay, let me close this one. So first it will download this model. Okay, there is no need to manually download the pre-trained model. When you will execute this cell, you will have this pre-trained model like this, and you'll see the output image like this. See, persons are getting detected and sports ball is getting detected. So this is how we perform object detection. Now let's say if we want to perform the object detection on a video and we also want to save this. So right now using this dot show, we can only see the output image. But what if we want to save that output? So for that, let me show you that. Let's copy the same code from here, paste it here, and this time we want to perform the testing on the video. Which video? Let's say we are performing this video. So let's try to perform object detection on this video. Okay, so the name is VID. So let's put VID.mp4 and then here just provide the parameter save equals to true. This save equals to true, what will happen with this? It will create a runs folder in your current working directory, and under that runs folder you will see the output video with the objects detected. Okay, let's run it. So it has started. Now let's go to our folder. Here you'll see the runs folder. Open it. Inside that you'll see a detect folder and then predict folder. Here you will see the output video. So let's open it. So this is the output video. So this is how you perform object detection on a video, and this is how you save that video. In the same way, if you want to save the image also, you can simply provide save equals to true with this also. So next task is, now we have tested the model on image and a video. Now let's say if you want to perform this object detection, real-time object detection, so we can provide different sources to it, right? So let's copy this one from here and paste it here. Now over here, we don't want to provide this video, we want to provide the path of the camera on which, from where we want to detect the real-time objects. So in my case I am giving 0. 0 means sources 0, which means your web camera, the camera which is attached with your PC. So when you'll run it, it will start detecting objects from the source, which is 0, which is your web camera. In the same way, if you have any RTSP stream or any camera URL, just provide it over here and it will start working, right? Now let's try to run the image segmentation model. So for that, you will paste this code. We are again importing YOLO, but this time we are using this model. So if you'll go to the Ultralytics repo, just scroll down under this segmentation section, just open it like this, expand it, and here you will see the name of segmentation models. So I just copied the segmentation model name from here and then I pasted over here .pt, and on the same image I want to perform the testing, and .show means show the result on the screen right now, and let's run it. See, we are getting some error, and what is it? The error is no such file or directory. That means, see, when we try to execute the code with object detection model, this part, at that time this model automatically got downloaded and saved in our current working directory. You can see here. See, we got this model. But when we are trying to execute this segmentation model, so it is not downloading that model automatically. So which means we need to download that model and to place that model in our current working directory. So for that you will go to this repo, okay, here, and just click on it. When you will click on it, download will start here. You will see that model over here. Just open the directory here, just copy this model from here. Okay, so you will copy the model from here and you will go to the directory. This is my directory. Okay, so just paste the model here. Now we have pasted the image segmentation model of YOLO11 in our current working directory, and this is a Jupyter notebook which I'm showing, and this is the model. Now once we place it, now let's run it. So here you can see that image segmentation is performed. So this is how you can use image segmentation model. In the same way, if you want to perform image segmentation on a video, just provide the path of a video over here. And if you want to perform image segmentation on camera source for real time, this image segmentation, you can provide the sources 0 or whatever your camera URL is. So next thing is to test the pose estimation model. So let's copy the same code from here. The only thing which we need to change is this model over here. This time we need to pick the pose estimation model. So for that, just go to the repo and come here and expand this section. From here, just pick any model. So I'm picking the first one only. Copy this model from here. Just write the name of that model. like this and hit enter, we'll get the error again. See the same error that this model is not in your current working directory. So YOLO Ultralytics repo is not downloading this model automatically right now. So you need to download that model manually and place it in your current working directory, and then you can test it. So for that, you just go here and click on it, and here it will start the download. Okay, so here you can see, just go to the folder, copy this model from here, and then you'll paste that model in your current working directory over here, right? And then run the code again. Now let's run the code again. So this time here you can see the pose estimation. You can see the key points on the person class. So for this key point detection, key points are this model is pre-trained to detect the key points of a person class only. So whenever you want to test the key point detection, just give the image or a video where the persons are there so that you can see the output. So this is how you can use pose estimation model. And again, in case you want to save it, just write save equals to true, and then the output will be saved. See, the output is saved over here. So, and it is also showing you the output on the screen. Now you can go to your runs folder, in the pose folder, predict, and here you can see the saved output, right? So now the next task is to test the model for image classification. So to test the model for image classification, what will you do? Just copy the same code again, and here this time you will write the name of the image classification model, which we can get from here. Just scroll down, and under this classification section, get the classification model. Okay, let me show you. Here, just copy it from here, and then you will paste it here, and we are testing on the same image. So again we are getting the same error that this model is not present in the current working directory. So we'll go here, we'll click on it, we'll download the model, we will get the model from this folder, just copy the model, and then you will paste the model in the directory where your code is, and then you'll run this code again. So let's run the code again. So here you'll see the results. Okay, so this one is not a good example for this. Let's try to test it on a different image. So for this, I have an image with the name of coffee. Just copy the name of this image, and then I'm providing this name over here. Okay, what is the error? Okay, maybe the file extension is PNG. So just change the name over here and then run. So when you will run, the result is stored over here, and we can also see the output. So this was my image, and these are the top 5 classification. The first one is coffee mug. So our model is 76% sure that this is a coffee mug, and these are some other classifications. So this is how you can use the image classification model. Now guys, if you'll notice this one, OBB, let's try to test this model also. But guys, as I've told you that this model is trained on this dataset, and this dataset, if you want to know more about this dataset, then you can click over here. But for now, you just remember that this dataset is trained on 15 classes. So whatever video you are trying to, whatever video you pick to test this model, make sure that that video is based on these 15 classes. Then only you will get the good results, right? So let's see what are those 15 classes first. Click on this and scroll down, and here you'll find a list. See. So these are the name of those 15 classes. So whenever you pick a video or an image to test this model oriented bounding boxes, for oriented bounding boxes, just pick the video related to these classes. So in my case, I have this video on which I'm going to perform the testing. Okay. So this is the video. Now let's perform the testing on this. and we will paste this. So this is the model, OBB model, and this is the video, and save equals to true, that I want to save this video, and let's run it. So again, we don't have this model, so you need to download this model. So for that, just go back to the repo, scroll down and go to the section where OBB model is, and then just click on the model. It will be downloaded in your downloads. Copy that model from here. Just copy the model from here and then go to your directory, paste the model here, and then go to your code again and then run it again. This time you will see that the process has been started. Now we can go in the runs folder, and OBB folder you will get, and inside that predict folder, and here we have the output. See, so this is how oriented bounding boxes work. Alright, so this is how we can perform different kind of tasks using YOLO11. In my next video, I'll show you how to work with a custom dataset. I hope this video is helpful. Thank you for watching.